Good morning, everyone. We are from Group 1. We will title Adult Video Classification using IMDb data. To give you some context, automatic adult content detection is a critical component for modern contents moderation system. With the massive influx of medias, manual checking is impossible. So we leverage IMDb large-scale structures metadata to build a scalable solutions. And our objective is to develop some logic regressions and random forest model for our adult contents classifications and compare the performance of both models. So in this project, we will prioritize recall as our evaluation metric because a false negative is more dangerous than a false positive. Our workflow followed by a standard pipeline, EDA, feature selections, modeling, and evaluations. And we specifically design a three-stage experimental, baseline, balance, and optimize, which I will detail shortly. We start by implement IMDb dataset integrates IMDb dataset into massive datasets of 12 million records. We handle the missing value in the ratings and runtime by using the group-based median derived from the parent series. After clean, we were left roughly 2.9 million records. During our analysis, we encounter a massive class imbalance. Out of 2.9 million titles, only 60K were labeled as adult. That is less than 2% of data. We also observed that the word count followed by the power loss distributed with a massive skew. To fix this, we apply a log transformation to normalize these distributions. We also apply hot encoded to genres, which expand our variable counts to 42. Before trends, we look for the distinguished pattern between adults and non-adult content. We found that there are three critical insights. So the structural integrations, adult contents will overwhelm standalone movies or videos. The have parent flag is a critical distribution boundaries, and the titles belongs to TV series are 98% are non-adult. For the engaged patterns, the adult titles propose slightly higher median rates, but slightly lower word count compared to mainstream content. For the tempo patterns, we notice a distinct productions increase in the adults contents post 1970s. Older titles are less likely to be categorized as adults in this dataset. To improve the efficiency, we reduce our dataset from 400 MB to 81 MB using the random samplings and informed grain ranking. We reduce the features from 42 variables down to 21 key features for this final dataset. In our model strategy, we construct an experimental three-stage. The stage 1 is the baseline, which we define the setting. Stage 2 is the balance, we using the background balancer. Stage 3, we attempt to using a feature animation to reduce the noise. In terms of weight average, the baseline model achieve a high performance. However, because of this imbalance dataset, the model favors the non-adult majority class and ignore the target class, ignore the adult class. The recall for adults is only 31.6%, and this means that the baseline model missed nearly 70% of all adult content, which fail our objective. While for random forest show that they are good in handling imbalance class. In stage 2, we apply a class balancer to the minor class. For logic regressions, the adult recall increased from 31.6% to 92.6%. For random forest, recall hits highest recall, which is 95.7%. So there's a trade-off in these models. So the overall accuracy slightly drops to 91% due to an increase in the false positive. However, our goal is to capture all the adults contents. So this trade-off was necessary and successfully. In stage 3, we hypothesis that the remove the weak features will be reduced in noise and improve our efficiency. But the result saw negative impacts to logic regression and random forest. Therefore, we reject the optimum reduced models. And it turned out we find out that the features that we thought is noise were actually necessary for capturing all the edge case in the adult content. Therefore, we determine that the stage 2 balance model is the final optimum solutions. Finally, we compare the two models in the stage 2. A random forest is the winners, recall with a higher recall, 96.4%, and higher ROC. We confirm that this random forest is better models by using the correct pair t-test with significance 0.05, showing that random forest is significantly different from the random forest logistic regression. In conclusions, we clean the data by integrate all the data, impute the missing data, normalize the data, balance the data. Also in our EDA, we identify the top predictor like the runtime and the title types. In our modeling, we apply class balancers, we achieve a higher detection rates. Ultimately, the random forest is the best model for this task and achieving 96.4% of recall and 99.5% of ROC. So thank you. That's all from our teams.